What is up, ladies and gentlemen? We're going to work on our Intro to Acceleration notes with a brand new unit, and we're going to tie in some stuff from the last unit, but incorporate some new things with this unit. The first one going to be is acceleration, then we'll go a little bit into energy, and continue on forward from there. Okay, so let's go ahead and get started. There we go. All right, graphing position versus time. Now, we've done this quite a bit up to this point, but I just want a refresher on what this exactly means. So when you read a graph, it is always for the slope of an object. It is always, change of y over change of x. I've seen it written this way. You can also y2 minus y1 over x2 minus x1. Or even then very simply put rise over run. So what I want you to get in the habit of is identifying the graph, but not only identifying the graph, what type of graph is it? So from that, you can then logic yourself through what does each part of this mean and where can I find it? So in a position versus time graph, the slope will tell us the velocity. And how do we know that? Well, if we look at rise over run for a position versus time graph, I got that backwards. Let's try this again. There we go. We got rise over run. This is equal to the change in the y-axis over the change in the x-axis. So what does that mean? The rise is recorded in meters, and the run is recorded in seconds. And so this tells me it's meters per second, which is the unit of velocity we're using for this class. So the slope tells us the velocity of the object, as long as it's a straight line. And so we can see right here that the velocity here is going to be positive, but not only was that, it's a straight line the entire time. If it was a curve, we know that the velocity is changing. And so right here, we see the velocity go from a positive number to 0. What is happening there? In this moment, when velocity goes from some positive number to 0, the velocity is now changed. So what is this object doing? And so overall, this object is going some positive direction, some positive distance. Let's use yellow here. Some positive direction. Let's use a nice thick line. Some positive direction, positive distance for some time interval for 5 seconds, and then it stops moving. So at this point, you should be following along. If not, it's a big red flag that we need to revisit something from the previous unit. You should be able to tell me that the positive slope in the first 5 seconds is meaning the object is traveling to the right or up, and then when the velocity equals 0 or the slope equals 0, you can tell me the object is not moving. Okay, so where do we go from here? Let's go ahead and do some more review before we hop into some new stuff. So the first thing we're going to do is describe what is this object doing quantitatively, meaning with numbers, okay? And qualitatively, meaning what is the qualities of it? And we typically just say this is without numbers. Or can you explain it to me in a sentence? So we're going to do the qualitatively one first. So for this first time interval, from time equals 0 to time equals 10 seconds, we should be able to see that this object has a positive slope here, so the velocity is positive. And that tells me the object is traveling to the right. And so the object's traveling to the right. Positive velocity looks good. What is it doing from the time interval? Let's do this in green. From 10 to 15. Well, the velocity here is 0. And how do we know that? That's because the slope is 0. All right. What about this next little chunk right here? We've got from 15 all the way down to 40. Well, this is a negative slope, which means the object is traveling to the left, or it could be going down. And then last but surely not least, what is it doing from this time interval to this time interval? And then that velocity again is positive because the positive slope means the object is going to the right or up. And so qualitatively, we've just explained the velocity of this object as being positive, and then it comes to 0 for some time, then it goes negative for some time, and then it goes positive again. So what did that object do qualitatively? So let's erase all this real quick. Okay? Let's explain the displacement of this object. What was it doing? This object was traveling to the right. Let's do a different color. Let's do blue. This object went to the right for 60 meters, and then it stopped. And then what did the object do next? Is if this is 0, 0, this object went to the left. What was that? That looks like 100 meters. And then the last thing is, what did the object do? It then turned around and went back to 0 for a positive 60. So we can also explain that this object did what this did by also explaining its displacement, qualitatively what's going on. So at positive 60, negative 100, positive 60 again, and so the object went right, left, and right. Okay, now let's do quantitatively. What is going on here quantitatively? Let's erase all this real quick. And let's explain this using numbers. So I'm going to very particularly, what I'm going to do here is I'm going to arrange this graph up here. That way it gives me a little more space to write, but also be very particular on how I write these numbers. So, velocity is the slope of our position versus time graph. So velocity equals displacement over time. We've done this for quite some time, so you should be good on that. So let's do the velocity for this first time interval, and that'll be from 0 to 10 seconds. How do we denote that? So I'm going to write the velocity from 0 to 10. Okay? And so you can write this a couple different ways. I've seen velocity equals, t equals 0 to 10, but I think that's a little bit too much to write. So I'm going to say the velocity from 0 to 10, and I'm going to denote it with that little subscript, equals the displacement from 0 to 10, and that was a positive 60 meters. The time interval from 0 to 10 was, of course, 10 seconds. And so we can collectively say that the velocity from the 0 to the 10 second time was 6 meters per second, which is 60 divided by 10, and there we go. Okay, so this is, let's write this over here. This is positive 6 meters per second. Okay, let's continue on forward, and let's do the velocity again of this little top part right here. So the velocity from the 10 to the 15 second time. Why did I choose 15 second time? Well, that's where this part is right here. So what is the displacement there? Well, that is 0, because it doesn't go up at all, it doesn't go down at all. The position is the same. So 0 meters over 5 seconds. And this gives me the velocity of the object right here is 0 meters per second. It is not moving, and we can say that really quickly because the slope right here is 0 as well. So let's go ahead and say the velocity here is 0 meters per second. Okay, here's what I want you to do, is I want you to try this now on your own for these two time intervals. So go ahead and hit pause in this video, try it out on your own, and then if you think you got it, hit resume and see if you follow along with me. Ready? All right, go ahead and pause. And I'm ready to get started. Okay. What I'm going to do now is I'm going to look at velocity, which is the slope, displacement over time. So the velocity is displacement went from positive 60 to negative 40. So what was my rise here? My rise over my run. Well, I went down 100. Because I went from 60 to 0, which is 60, and 0 to negative 40. So I went down 100 meters and over, let's see, this is 5, 10, 15, 20, 25 seconds. Okay, so here's what we can say so far. It's negative 100 divided by 25. The velocity equals negative 4 meters per second. So if you got negative 4 meters per second right here, we are looking fantastic. All right, and last but surely not least, I want you to try this last little portion right here and see if you get the same answer as me. Okay. The velocity here equals displacement over time, or rise over run. It went up 40 meters, so we're going to call that positive 40 meters. And your displacement was 5, 10, 15 seconds. Is that right? That is. Okay. And this is going to give us a decimal answer. And so we just plug into our calculator, 40 divided by 15, and that should be 2.67 meters per second. We're going to round it to the hundredths place, should be 2.66666. Just round it to 2.67, and we're good to go. Alrighty guys, that's it for when it comes to looking at a position versus time graph and remember what we can get velocity out of it. So let's go ahead and put negative or positive 2.67. Let's try that again. Positive 2.67 meters per second. Alrighty. Are we looking good so far? If not, write down your questions off to the side and bring them into class, and I would love to help you out. Okay, what can we do next? What happens if there's an increase or decrease in acceleration? So let's go ahead and move this around a little bit. Acceleration is an increase or decrease in velocity as in the units of meters per second squared. So something brand new. What we've done before is we've looked at dropping a ball. We did this in class already. We took a ball and we dropped it from the 1 meter height, and we found out that, or at least we should have found out, that as we dropped the ball, the higher and higher we dropped the ball, the faster and faster it was going. And so the first height we dropped it from was not very tall, but at the tallest height, which was the 2 meter height, we found out that the ball was speeding up as it was getting closer to the ground. And it was going the fastest it was going right before it hit the ground. Now, some people, because of their timers not working right, they had a hard time with this lab, but here's what should have happened. What we should have noticed is that something as it falls towards the earth, it will speed up. It will go faster and faster and faster until it hits something. What is going on exactly? And that is, it is accelerating, or the velocity of it is increasing as time goes on. And so another one we talk about in this class is, or another way is we talk about a car. If I got a car, let's draw a very poorly quick car right here. And we're sitting at a stop sign. The moment we start to go forward, we go from a 0 velocity to, let's say, 10 meters per second by holding on that gas pedal. which the true name for the gas pedal is called the accelerator. This is because it accelerates the car forward. And so over time, it's now going 10 meters a second. However, if you keep your foot on the gas pedal, over some time, you'll start to go, 15 or even 20 meters per second. And the car's even going even faster. So what is going over time is that the speed of an object is increasing. And so velocity can be defined as speed or direction. For right now, we're just going to talk about acceleration as being the increase in speed, and later on we'll talk about the changing of directions. But how do we calculate it? Well, very similar to velocity being displacement over time, acceleration is just the change in velocity over time. And so if you start to think about what does this mean for this class, is that we can start to use these variables. We see some variables are in both of our equations. We got velocity here and we got velocity here. We have time here, we have time here. And so what we're going to start doing is we're starting to play with these variables and see how they interact with each other. Okay, so acceleration, increase or decrease in velocity. Okay, let's try looking at this out as a practice problem. So what is the acceleration object that was traveling from rest and then increased to 8 meters per second in 0.5 seconds? So let's just call this a ball. It was at rest to begin with. What is the velocity of the ball at rest? Well, initial velocity equals 0. And then increased to 8 meters per second. So it was going to the right or it was going up, and then the time interval is 0.5 seconds. How do we then use a formula that we had on that previous slide? What do we do here when it comes to velocity? Well, what we're going to do is unpack this just a little bit, and hopefully in terms, and you're welcome to use whichever term you like best. So I'm going to show all three, and then you can use the one that you like the most. I personally enjoy the change in velocity or the change in time because what that looks at specifically is it helps me to remember that I'm looking at how much the velocity was changed, not the final velocity. So what's another way we can look at this? So we could do V2 minus V1 all over T2 minus T1. This is beginning to look a little bit like the slope formulas we did earlier. And we're actually going to use this a little bit later, is that acceleration can actually be determined by the slope of a graph. So, or you can say the rise of velocity over the run of velocity, or sorry, the run of time. All of these work. You can use the one that fits you the most or the one you're most comfortable with, but all of these essentially say the same thing. What I'm going to do in this class is I'm going to specifically just say change of velocity of change in time. And if you've never seen this symbol before, this is called the delta, and this is just another word to say change. Change is, delta means change, but scientists and mathematicians like to be lazy and shorthand things as much as possible. So how do they do that? They just say, well, delta means change, and I don't have to write out the word change every single time. Okay, so back to this problem. All right, what is the acceleration of an object that was traveling from rest and then increased to 8 meters a second in 0.5 seconds? I'm going to do this problem kind of two different ways to show us we're going to get the exact same answer. So the first way I'm going to do it is the way I prefer to use the formula. Change in velocity over change in time. Well, what is, acceleration. Let's write that. Let's fix that real quick. There we go. That's my fault. I'm trying to do too many things at one time. Acceleration equals change in velocity, change in time. So, what was the change in velocity if we started at 0 and then went to 8? Well, I went from 8 to 0, from 0 to 8, so I'm now positive 8 meters per second. That was my change in velocity. What was the change in time? And that is going to be 0.5 seconds. Plug it into my calculator. 8 divided by 0.5 will get us 16 meters per second. Uh-oh, do these seconds cancel out? Well, both these seconds are technically on bottom. So this turns into meters per second squared, or 16 meters per second per second. And so both of these annotations mean the same thing, is that since the seconds didn't cancel out, it became squared. So acceleration is in the units of meters per second squared. So displacement's in meters, velocity's in meters per second, and acceleration is in meters per second squared. Okay, there we go. There's one way to do the problem. Let's do it the other way, it's going to get us the exact same situation, but it's using that equation, whichever feels most comfortable to you. And I'm going to use the V2 minus V1 minus all over T2 minus T1. Okay, so let's unpack this a little bit. What is my second velocity? Well, that's this velocity right here. It's my velocity after it has started. V1 is my initial velocity, and it's what we had to begin with. So V2 is going to be positive 8 meters per second, and V1 is going to be 0 meters per second. T2, uh-oh, what are we going to do here? Well, that was the time that elapsed was 0.5 seconds. So that's going to be T2. So what do we use as T1? Well, we're going to say at time equals 0, or when it all began, that's when we're going to use as time equals 1. And so we plug and chug in here the same way, we find out that this is going to get us to the exact same answer. Because 8 minus 0 is just 8 meters per second, and 0.5 minus 0 is just 0.5 again. So this is going to get us again to the same answer. So I don't care which approach to the question you want to do. You can do change in velocity, change in time, or you can do, y2 minus, v2 minus v1 over t2 minus t1. Both are okay. Use whatever you like, whatever you want to use most. Okay, so what is this object doing then? So I'm going to erase this a little bit and go back to the picture we have here. So what does this picture tell me? This tells me that as time goes on, this object is speeding up to the right. Speeding up to the right. Well, that means the acceleration is positive. Because as time goes on, it is accelerating in the positive direction. So acceleration can be positive to the right or up, and negative to the down or left. So let's do a little bit of a thought experiment here. What if my object had an initial velocity of 8 meters per second, but then stopped after a time of 0.5 seconds. Okay? What would that then be? This is positive 8. There we go. All right, here's what I'm going to say is, if you watch this video, come in tomorrow in class and tell me the answer you have here, and I'll give you a piece of candy if you got the question right. If you got it wrong, show me down your work, and I'll show you where you got right, and I'll still get you a piece of candy. All right, that is for the people watching this video and looking at its entirety. You guys are doing awesome if you're watching this far. Okay, let's move on, and we are almost done, but we're going to leave this to be on for later. Okay, let's do practice number 2. What is the acceleration object that is traveling at 10 meters a second? So this is my initial velocity, and then decrease to 0 meters per second. That's my second velocity in 3.5 seconds. So this is my change in time. So I'm going to use just one formula here. Change in velocity over change in time. And that's going to be, if I went from 10 to 0, my change in velocity was negative 10 meters per second, because we went from 10 to 0. My time then is 3.5 seconds. 10 divided by 3.5, grab your trusty calculator. Let's go ahead and grab mine while we're at it. 10 divided by 3.5. I know there's going to be some ugly number. That gives me negative 2.86. And what's the units for acceleration again? That is meters per second squared. Okay, let's use this again with the other formula type, where acceleration equals velocity 2 minus velocity 1 over t2 minus t1. So velocity 2 was 0, velocity 1 was 10, t2 was 3.5, and t1 equals 0. So that still gets me to 0 minus 10, which is negative 10 over 3.5, and gets us to the same answer of negative 2.86 meters per second squared. Okay, we get the same answer here as we do right here. All right, what is this object doing? So let's draw a picture. This object was initially going 10 meters per second. And then it's now going 0 meters per second. It has slowed down. Or what we can say, it has accelerated in the negative direction, meaning it is speeding up in the negative direction. Okay, this is something that is really tricky for some people to wrap their minds around, so just kind of chew on it for a little bit, saying something slowing down is actually speeding up in the other direction. That's why we don't say the words like deceleration, is because you can't, something that doesn't really decelerate, it just speeds up in the other direction. Okay, if you have any questions about this part, absolutely bring them in class on Tuesday, and I'd love to help you out. Okay, this is going to be the last little bit, and then we are going to move on with our lab, and I'll see you hopefully in class on Tuesday, and we can do some of this stuff together. All right, what are we going to do now with a velocity versus time graph? Uh-oh, just dropped my phone. Okay, all right. Well, if the slope of a velocity versus time graph, which is, rise over run, well, the rise would be change in velocity, and the time would be change in time. So the slope of a velocity versus time graph gets me acceleration. So here's what you should be able to do at this point. There are two types of graphs that we've seen. We've seen a displacement versus time. Let's move this off to the side now we can see. Let's do this. Let's do a displacement versus time graph. And we have a velocity versus time graph. Both of these could look exactly the same. But where do I find my information? Well, in a velocity versus time graph, the velocity is your y values. But in a displacement versus time graph, the slope is velocity. And how do we know that? That's because that's change in displacement over change in time. Okay, what does the slope of this graph now get us? And that's acceleration, which we just talked about was change in velocity over change in time. So even though these graphs look very similar, they're actually two different situations. They're not the same thing. So here's what I want you to be able to do. Look at what kind of graph you have first, and then figure out what information you can tell from it. Once you got that part down, You're looking really good. Okay. So, the slope, rise of run, change of velocity, or change of time gets you your A value, or your acceleration. So, if I start at 0, 0, and I go from 0 to 20 in 5 seconds, my acceleration then, or my change in velocity, is 20 meters per second all over 5 seconds, which gives us a positive 4 in acceleration, meaning this object is speeding up to the right direction. Every second it is going to be going faster and faster. So let's unpack that just a little bit. After 1 second, it's going positive 4. After 2 seconds, it's now going positive 8. So if we notice here that every second goes by, we're adding 4 meters per second to our speed. Well, let me erase that just a little bit. As time goes on, we are speeding up. Every second passes by, we are adding 4 meters per second. And then to the final time, which would be 5, we get that final speed of 20 meters per second. So as time goes on, not only is this object going to the right, it is speeding up the whole time. Okay, here's what I want you to do for me. All right, try this one out. Calculate the acceleration and tell me what this object's doing quantitatively and qualitatively, using both in terms of acceleration. What is this object doing for acceleration right here, 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 and here? What are those acceleration values? Okay, so go ahead and pause in this video. See if you can take a second to see if you can figure out and determine, is this object and what is it doing? Okay, I'm going to go ahead and move on forward though. So what I can say is that this object the acceleration is positive. It is speeding up here and here. And how do I know that? Well, that's because the slope for these two line intervals right here are positive. That means the object is speeding up to the right. Okay, what about the velocities? And this is where probably is the trickiest part, looking qualitatively. This object, when it very first starts out, it is going 0 meters per second. After half a second, it's now going to the right. And then, so it has sped up right here, and now it's going to keep going that speed for some time. And then, right here, it's going to come to a stop. And now, after some time, it's going to be going in the negative direction. And that's going to then very quickly turn around and start going, then it's going to start coming to a stop again. Let me erase right there real quick. So what did this object do overall? It went to the right. It accelerated in the right direction, maintained a constant velocity for some time, slowed down or accelerated in the negative direction. Now at this point the object's not moving. And now it's going to the left, and then it's starting to slow down again and then come back to 0, 0. Okay guys, this is a pretty tricky example, and I want to see if you can follow with me. If you have any questions, bring them into class on Tuesday, and I'd love to help you unpack it. But now all we need to do is calculate the acceleration for these time intervals. And then we're going to call it done for today. Okay. The acceleration from 0 to 0.5 seconds. Let me write that just a little bit better. acceleration from 0 to 0.5 seconds, or this time interval right here. My change in velocity was 3 seconds. My change in time, let's try 3 centimeters per second. And my change in time was 0.5 seconds. So I went up 3 over 0.5, so the acceleration for this first time interval is going to be 6 centimeters per second squared. Where did I get that centimeters from? Well, the graph is in centimeters right here. Okay, what is the acceleration value for, let's do this different color, right here? Well, the acceleration would be change in velocity over change in time, and so that's going to actually be 0. That's because it's not speeding up or slowing down. It is maintaining a constant speed. Okay, and then let's move on to the next one. So acceleration for this 2-second interval to this 4-second interval, so 2 to 4, equals change in velocity, so that's from 3 to -3, so I went down 6 centimeters per second in 2 seconds. So -6 divided by 2 is -3 centimeters per second squared. I forgot to put my final answer over here, so let's put that in there. There we go. Alrighty, so this time interval is -3. Alright, what about the very last one? From here to here. So acceleration from 4 to 5. I went up 3, so +3 centimeters per second in 1 second. Gives us a slope of +3 centimeters per second squared. Alrighty, ladies and gentlemen, we've really unpacked acceleration and looking at it, how to find it, what is it. If you have any questions, comments, concerns, feel free to reach out to me in whatever way you feel necessary. What I would like you to do is to use what we now know for acceleration with this motion mapper. And so hopefully, as time goes on, what you can show for me is your... Sorry, I was a little confused about what that progress board is. I was intrigued by it. I want you to play around with acceleration. So what we've done so far is we did the set velocity, and you have those 16 levels done. Let's look at position versus time for acceleration and velocity versus time for acceleration. You're going to use some of the skills we just talked about to graph what this little blue dude is going to be doing during that time. So at the very beginning, we have to look at, okay, what is his velocity at the beginning? That's 0. So time equals 0 seconds. If I give him 0 velocity, something's not quite right. So what is it? As time goes on, his velocity is going to increase. He's going to speed up. So how do we find that? Well, it looks like 4 seconds, he's now going 4 meters per second. So what is the slope of this line? Up 4 over 4 is +1. And there we go. We just found the slope of that to help me determine what his velocity was. Okay. All right, at time equals 0, he's not going to be moving. So at 2 seconds, what is he doing now? You then use this to help calculate the acceleration of the object he's doing. Same thing for position versus time. However, we're going to run into some curves here. And why is that? And that's because as time goes on, since he's speeding up, the slope will be constantly changing. And so it's really difficult to calculate this change in slope. So you kind of just eyeball what's going on, and then from there you can figure it out. Okay. Good luck, guys. If you have any questions, comments, concerns, feel free to reach out to me however you need. Good luck, and I will see you guys on Tuesday.